Ryan offered me like $100.
I would have taken
You
it.
really?
Yeah, but then Senor found out about it.
That's just lazy. I wouldn't have given it to him anyway.
I don't know.
I
if it's a
like
fair
$100.
price. It seemed really cheap.
It's really cheap.
Considering-
$500, $1,000.
Considering how much
then
time
you
I
might
put into
compromise your
it.
ethics. I won't.
Then you might call.
I think
No,
I could.
what I would do is
I just feel like
Right?
I want to get the Songbird edition of Bioshock, which is $150. So if I just $100 up here, then it'd be like I was just buying a normal video game and nothing happened. I would never think about it.
Compromising your ethics.
Songbird.
It's expensive.
Statue.
Expensive, I agree. Okay, so here's what we want to do. So you've watched the video for introducing solids of revolution. So let's do a couple more examples. Let's do one like this, and then maybe do one more, and then we'll give you guys some time. So first, of course, the key is to draw. You must always draw these first, and then really focus on that rectangle, okay? So 2 minus x squared looks like what?
Can we use our calculator?
Upside
No.
down,
It's
upside
gonna
down,
be
up to.
It's an upside down parabola shifted up 2. Negative x squared looks like this,
Oh.
up 2. Yeah? So it looks something like this. There's f, the region bounded by it, and y equals 1. Y equals 1 is right here, you guys know that. So the region that we're investigating is right here, right? But it's not just find the area of that region anymore like we did in 7.1. Now we're going to take that region and spin it and create a solid in
So
three
it's going to be like a
dimensions.
weird, like almost circular thing.
There's a hole
Yes,
in
it's
the middle of
almost
this one.
what? This is like
An
a...
annular thing.
Sphere?
Is that the
It's
word
like
you're
a
looking
sphere.
for?
We
Like
did
half
this
of
kind of
it's
thing.
kinda half a
No,
sphere.
I think it's a complete sphere, except this sphere has
A
a
hole in the middle.
hole.
So a
That's what
hollow
kind of
sphere?
hole?
A washer.
This has a cylindrical hole drilled out of it. So we'll try to look at
Which
it.
is y
So-
equals 1.
But wait, why does this one?
Okay, so first, the idea is we focus on a rectangle. I think this one can be done vertically.
But Mr. McGee, I didn't think you had. I didn't think this one had a hole because what you're revolving it around
You're
is
revolving
part
it.
of is touching it.
Okay, I am revolving it around this line, right?
But isn't there not a hole because it's touching it? I thought.
Let's see, maybe you're right.
I thought because it's touching it.
You're right.
Oh, you're
That
not
was in a
revolving
hole.
around the axis.
Like if you did it around the axis or something.
X-axis?
Yeah.
You guys are right. So this one would be like
This would be a.
almost a sphere. It's not perfect sphere, is it?
This
Like a football.
this one
like-
would
yeah.
be.
Yeah, it's like a football.
So on this one we would use the circle method or whatever, not the circle method, the disc method.
Just nice discs, yeah.
Can we try?
The washer method isn't that much harder. If you really understand the discs, we're going to be fine with washers too.
Why does
Okay.
that rule
Let's take a picture.
Okay.
in when it's integrated?
So yeah, I was thinking that we could do both. Let's do both. We can do both. I mean, it's just me changing the problem. So let's do both. So if we do the first one and we revolve around this line, you guys okay? I like Todd's analogy of football because it's basically going to look like this then, right? Except we're also imagining that coming out of the board at us. Okay? It's like a football. So we're going to focus on this and we're going to integrate from where to where. Notice, I like to focus on this. Are we doing dx or dy if you look at your rectangle?
We're doing axis.
dx.
Dx, right?
So
go
it'd
to
be
dx.
from-
I always like to start
What do we have
there.
to calculate the zeros? Or not the zeros, where it crosses.
We
have
do.
to calculate the
Yeah,
intersections.
we'll do that too. Good. You want to do that first? Okay. So Austin's saying, where do we stop? Where do we start integrating? It's obviously like -1 to 1. Where is it? You could just set them equal to each other, right?
Why don't you just
2 minus x squared equals 1. What is that? Negative x squared equals -1, x squared equals 1. Oh,
1 and -1?
it is 1 and -1. That looks right. So we go from -1 to 1. That's where we're going to add up our discs, right? And now you just have to think, what is the area of each individual disc? It's like, it's a cylinder.
So you need a pi out there.
Yeah. The bottom of the disc is going to be pi r squared. And this dx gives you like the height of the cylinder or the width of the disc.
R is the 2 minus x squared.
Something like that, yeah. That's what you've got to be careful about though.
Is it?
Do you guys understand though? This is the concept. This is a disk. Pi r squared, if we pulled this disk out, we've got like this, right?
Yeah. So.
Pi r squared is this. Then you multiply it by how wide the disk is, which is dx, and then you add up all the disks that you can stack up in there and you get your area. So don't make it like super hard. The thing that you really got to be careful about is the radius. So what is the radius? For us, it's just this. Be careful.
What's
Okay.
just the?
How big is this radius?
That's x squared minus 1.
Yes. 2 minus x squared gives you this distance, does it not? Because that's the distance up to the curve. But then Anna had said, well, you don't want this part, do you?
So 1 minus.
So she subtracted out that one.
I was just taking this.
That's how it
2 minus x squared is all of this. We don't want all of this for
Oh.
our radius. We just want this part.
Okay, because that's from
So she
is this from
subtracted
0 to
out
1.
that. That's from 0
Okay.
to 1. Okay, that's what you really got to focus on. That's where people go wrong in this.
So it'd be 1
1 minus x squared.
Yeah, so then you simplify and then it's probably not a big deal. Once you've got these set up, doing them's not going to be hard.
Can't you pull your pi out in front?
Yeah, excellent, I would. Very nice. So then they said that's 1 minus x squared, and then you just do it. So you get pi times, what is this? X minus.
It's 1 minus x squared squared, isn't it?
Oh.
Yeah.
Oh, x to the fourth
Dang it.
plus 2x.
So how do I do
minus
that then?
2x squared.
Would
I
you
would-
square
Plus
it
1.
and then
I would
take
go
the
ahead and square it. And
I think squaring it and getting the pieces would be easier for integrating. Otherwise, we'd have to have like a u substitution, and there's no 2x out there, so I don't even think that's going to work. So let's square it out. So you get 1.
Yeah, minus 2.
minus 2x squared plus x to the fourth.
Okay. Foil it if you need to. So foil it if you need to. I use the shortcut formula. So now I can do it. Now I can integrate. Now that's x. This is
better eraser.
2x cubed over 3. This is x to the 5th over 5, negative 1 to 1. Let me let you guys finish.
Okay, this is terrible.
Oh, you'll survive.
No, I said it wasn't as bad as I thought.
Yeah. The real thing is you got to be careful about that radius. If you can get the radius down, it's not going to be a hard thing. Okay. It's the radius that used to throw me off too. I'd have trouble. But I worked hard and I got it. So can you guys. I should have brought a football in.
What?
Mr. Bailey has one in his room.
It's really deflated, but
This is not a deflated football, that's true. Do I have another good example? Let's see. Good.
15, so 30 minus
No, that's not what I
20
did.
plus 6 and 15.
Ooh, that's a good one.
Did you get the stats quizzes graded?
Yeah,
How were they?
they're pretty good. You
Okay.
did really well. You have the highest so far. I assume you have.
Did I do okay?
Yes, you did. Most people did well.
Yeah.
Most both did very well.
I was worried. I
No, you
thought,
did very good.
Like,
What I
I
noticed
didn't
you
take
just
all
be
the
like,
time.
you might want to take a look at it when I asked you how they went.
Miss Ryder made
Do you have
that
the
for me.
answer?
She made the beat.
I got 16 over 15.
And then my aunt.
Probably so much.
For me.
Do we have the answer?
Oops.
I got 16 over 15 by the way.
I'm gonna
got
put this in
16
case
pi over
16
Yeah,
pi over
16 pi.
15.
That's-
Do not forget your pie.
So let me show the work just for anyone who's watching the video. So you get pi, leave that all the way out here. Use my parentheses notation, right?
I messed up somewhere.
1 minus 2/3 plus 1/5 minus negative 1. You put a negative, it becomes negative, but that
So,
makes it
plus 2/3.
positive.
Sorry, I
Negative is negative.
Okay, I had all that.
And then it's 15.
It's easy to make mistakes on this. So 1 plus 1 is
2.
2.
Minus 4/3 plus 2
2.
fifths.
Minus 4/3. Yeah, I agree. 1/5 plus a fifth is 2/5. Pi times, what's the common denominator? 15.
30.
So we say how many 15ths is 2? That's 30 15ths. How many 15ths is 4/3? You've got to probably go like
20.
times 5 minus 20. 15ths
So 6.
plus 6. So you get pi times
16 15.
16 over 15, which approximately is...
Why don't you just do exactly 16 pi?
You would. That's more beautiful, isn't it? But in case you wanted like a way to think in your head how big that is, what is it? It's like, that's like 3 times 1,
3.
right? It's like 3
It's
something.
3.351.
3.351 what?
Units.
0. Well, okay, you want me to continue? I was like, I did round it
Oh, yeah.
correctly, thank you.
This is a volume, right? Okay, let's answer the same question, but instead of revolving around the line y equals 1, what if they said...
The x-axis, would that help?
Yeah, let's do that. So if they say and this, and then they say revolve it though, because they can ask you to revolve around anything around the x-axis. That's a totally different ballgame. This is not a football anymore, right?
No.
It's a football with a hole.
I don't even know if it's so much of a football,
It's
but
like
yeah.
someone shot
It's more of
a
a
hole right through it.
sphere.
Yeah, it is. Good.
Man,
I like
that was
that.
terrible. Don't say that ever again. Oh my god. Okay, now it's worse.
Okay.
Stop talking about it.
So, it's kind of like you do like a mirror image of this parabola, right? Kind of like this, maybe? Something like that. This is the x-axis. And then you think about this part. Really, it's being twirled around. So this is like a semi-spheroid. And then it's kind of like, I like Austin's. It's like somebody shot a hole through it. So there's like a cylindrical hole in it. Does that make sense?
So, it's like a...
Anyway, if you focus on a rectangle, it's still going to help you. Okay, I don't think this is
So
so
like
much
total,
different.
there's like the hole in the middle is like 2, like up.
Yeah, so when this is a washer method problem. Do you guys agree? So it's kind of like you've got big washers with holes in the middle of them. So remember, when you do a washer method problem, how do you set it up? You integrate. There's like 2 parts. Pi big R squared minus pi little r squared. So really, it's just the same thing. And then you do dx or dy. Ours is a vertical, so we're going to do dx.
So is
okay.
little
Are these gonna
R
change?
Is going to be
is 1, right?
yeah.
Okay. Okay.
Yeah, is this going to change for us? Are we still going to go from here to here?
No, we are. It's gonna stay the same.
That's still dx. It's the only thing that's changed is we've got to subtract out an extra thing. Now let's be careful here. Big R. Big R. I need another color, really. I don't have one.
Big R is 1 minus x squared.
I guess I'll use red again. So big R is what? Isn't that this?
Okay.
Oh, yeah.
So then
That
it's
is 2 minus.
That is
2
big
minus
R.
x.
Is it not? So that's just wherever you hit the function curve up there. So that's just our 2 minus x squared squared. We can factor this. This pi's in both, right?
Yeah.
So you can just factor it out totally in front, can't you? I like to do that. I like to use a big bracket guy to remind myself that these are different things. Yeah. 2 minus x squared. Because remember that we're saying this is the big radius, so that you get your big radius, and that's just how high the function is. Because that's up on the curve, which is 2 minus x
I still don't
squared.
understand why you'd go all the way to the x, because that's like there's nothing there.
You want this whole dimension, so that then you're basically going to like pretend that you could just do the whole sphere, and then we'll subtract out this
Oh,
bullet
okay.
hole shot
okay.
thing that you said. So we're just going to get like the whole thing. You can imagine it all being blue, and then we'll subtract out that corridor in the middle
Oh.
we've shot out of it.
So
Okay.
that's just 1.
So that's like the whole thing, pi r that squared. And then we've got to think about the corridor's little r. So what's the corridor's radius? Isn't that just 1? Little r that we're going to subtract out has a radius of just that 1.
So then if you...
So you go minus 1 squared dx.
What is that? 2 minus x squared.
So you guys have a shot at that, and then I'll put it out for you in a
Just
section.
kidding.
Okay. Should be a very different answer, I'm thinking. Maybe not so different, but certainly very different problem. Let's see, what was I thinking for assignment?
It's not going to be the same, Brett, because it's 2, not 1. The r is 2 minus x squared.
That's what you had before.
Okay. No, it's not. We had 1 minus x squared before.
Oh, yep.
Sounds angry. He doesn't.
He doesn't seem mad.
Maybe 60, 90. Minus 20. Pi over 15
I'd like to reiterate, because when we're doing these calculations, a lot of the time it seems like someone's engineered them for us, right? But remember, this is like you and the universe. This is you and the universe. It's not you and another human being from the past.
I already messed up. Ugh.
Such a silly person.
I don't understand how'd you get 3x in?
How did I? Which one?
Oh, there's a 1.
It's 50.
I wanna
You can do them separately.
I did the
Just
same
to work.
thing. It's 4.
Just gonna be more terms.
I know, I didn't even see that though.
If you do them separately, it will still
I
work.
didn't, I just forgot about the 1.
Oh yeah.
Did you get 56?
That one. Sorry.
What?
Oh, okay.
Yeah, you should.
Oh, we got 15ths again.
Didn't change me
Yeah.
very much.
90.
And 45.
Oh, you're gonna put them together, okay. Plus.
Oh, I should have put them together.
Yeah, because it's 6 minus 8
Bad
thirds plus
move.
2/5.
Oh well, I should have put these together first, right?
Well,
That
can't you
would've made
just
this
multiply
easier.
that by 2 because it makes everything you're just adding it on. They're
Yeah.
the same, so just multiply
That's double.
the double.
That's double.
Yep. So just multiply it by 2.
Yes. Smart. So 45 minus 20 is 25, minus 3 is 22, times 2 is 44.
45.
That's more volume,
Don't
isn't
you
it?
have to-
It's more volume
It's
than we got last
plus 3, plus 3, not minus 3.
Yeah.
Isn't it?
So you get 56.
I
Yeah,
combine.
you would get 56.
time. Yeah, awesome.
I combine them and then I don't know.
45 minus 20.
Good
I
job.
had 6 because
Six?
when I combined my 3, I had 6.
Yeah.
Six.
So
So do I.
to make it 6 over 15. 15, wouldn't you have to do 6 times 15?
6 times
Yep.
15 is 90.
Yeah, okay, that's
90.
what I had.
Minus 40 is 56, the whole thing. It's not.
Yeah, you're doing it right. Follow yourself, Austin. You're good at this stuff. You have to follow me.
something.
What
What'd
did
you
I
get,
even
though?
have 44.
56 pi over 15.
I can look at it with you if you want. So what is it?
I don't.
I had 28 points,
56
but I
over
don't think I'm right.
Is it 56?
Yeah,
Yeah.
because 45 minus 20 is 25 plus.
56.
Yes.
56 pi over 15. All right, let's just leave that.
Okay.
There we go.
Then you don't need the about, you need
You need units cubed.
units cubed.
And I need that. Thank you. Okay, I'm thinking we'll do one more, should we?
Okay.
Cool.
Why don't we get our assignment now so we have some class time?
Yeah.
I don't care. We can do another one tomorrow.
Okay.
That's fine.
Let's do that then. That's fine. All right, so I'll do another one tomorrow.
Devious.
Smart.
Devious.
Wednesday.
No, we're not. I think we're getting tomorrow night. I think it's
So
done.
we have to partition the.
I don't know, I think our game's at
pornographic
7 or
novels and
6. I don't even know.
Oh, so you're gonna be.
Why would you say that?
Because that's what she calls it.
Swing.
But it's not, I looked at it. It's not bad at all.
And that's what Senora says it is.
Okay, so
There's
we'll make
one
that.
part.
We'll make this is a little longer than the last one, so let's make it do Wednesday. We'll do part 2, do Monday, but I'm gonna put something else with part 2 as well. So
Oh yeah.
I'd, get on it. This week's gonna be a little rougher, and then next week we'll start taking it easier. I think.
We get 2 rough weeks and
Yeah.
Rough week in stats and Calc, no big deal.
Well, next week is TCAP.
I think the good news is an AP comp, it's not a rough.